So tonight we're going to be looking at microevolution. So there are two types of evolution that most people think of, which is micro and macroevolution. We tend to think of evolution in terms of animals. We've been looking at it cosmically, now we're going to look at it on our Earth with animals. So microevolution is simply a change in gene frequency within a population. Evolution at this scale can be observed over short periods of time. For example, between one generation and the next, the frequency of a gene for brown coloration in a population of beetles increases. Such a change might come about because natural selection favored the gene, because the population received new immigrants carrying the gene, because of mutation, or because of random genetic drift from one generation to the next. The example I have here is of birds. Let's say you have these kind of birds, which have larger beaks. These are great for breaking nuts. So you go and they break the nuts and they eat the smaller pieces of the nut, whatever. Or they break the shell around it and they eat the nut inside. That's what they're great for. They're really great at doing that. They're not, however, that great at digging down into holes and taking out ants. That's what these are great for. And so if you have this kind of bird in a place where it has those kind of nuts that it can eat on, this is the one that's going to survive better. This one's not going to survive so much. The beak's too small. It's not going to be able to break it as easily. Vice versa. So what happens is when this one starts to move over to the place where this one's at, and they start to interbreed, you start to get ones that are like this, a little bit in between. I can still get the ants, but I can do some other things. And I can still break the nuts, but I can do some other things. And so you start to get those things where they start to change. That's the kind of idea of microevolution, that you get these certain adaptations where certain ones mix together, they share their traits, those traits become new traits. Not necessarily new as in, they didn't just form antennae, but it formed different kinds of beaks. And we'll talk about that more as we look at mutation, which is one of the other things it brought up. Another issue before we continue on, terminology. One of the biggest problems we have when talking about evolution is terminology, the words we use. Let's define terms. If we don't define terms, then we come up with a lot of issues. And so this is what, biblically speaking, I think the best way to look at it is kinds and species as something separate. Closely related, but separate. The issue with species in science we'll look at now. So this would be a cat kind, and this would be a dog kind. There are two different kinds of animals. However, these would be different species of animals. And so you have the cat kind, and within that cat kind you have different species. The issue is, scientifically speaking, the way they use that terminology, this is a different species than this species, and these species are different than that species. But you'll notice it's still the same word. That's the issue. So obviously these are different species, but then these are different species, but they're still cats. And so you get that confusion. And so a lot of times we talk about, what's the evidence for evolution? They say, well, we have so many different species. But what do you mean by that? That's kind of the issue. And so the way I'll be talking about it tonight, and I think a good way to talk about it is you have the cat kind, and you have the different species within that cat kind. You have the dog kind, the different species within that dog kind. But they're still dogs, even though they're different species of dogs. Still cats, even though they're different species of cats. You can see that also with like horses. You have horses, you have zebras, you have donkeys. Now we would call those the equine kind, or the equinus, or whatever. Where they can breed together. They can make a zebra and a horse, a zorse, or you can make a zonkey, those kind of weird things, because they're able to breed together. And they're definitely similar, and they seem to have a common ancestor in terms of that way, because they're that same kind. But you're not going to get a donkey and a dog. That's just, I don't know what you call that, doggy or something. But you're not going to get that because they can't breed. They're different kinds of animals. So species can breed together mostly, and different kinds cannot. So that's kind of what we're going to go for going forward. Let's look at Genesis chapter 6 and verse 19 through 20. Genesis chapter 6, verses 19 through 20. This is kind of our baseline for that, our reasoning for holding to that. And it says, "And of every living thing of all flesh, 2 of every sort shalt thou bring into the ark to keep them alive with thee, and they shall be male and female, of fowls after their kind, and of cattle after their kind, of every creeping thing of the earth after his kind. 2 of every sort shall come unto thee to keep them alive." And so that's kind of the idea. You have different kinds of animals. You have the cattle after their kind, and the creeping thing after their kind, right? The ant kind, the spider kind, the praying mantis kind, that kind of stuff. The fowls after their kind, the raven kind, the pelican kind, that kind of stuff. So according to the Bible, that's kind of how we hold to it. It says kind, we just say kind in terms of different kinds of animals. And we use speciation just so we're not getting confused. I think it's the best thing if you want to talk to anybody about micro and macroevolution. Just start there. Kind and speciation, we're going to be talking about 2 different things. We don't want that confusion. So with microevolution, it is an observable fact that that it does exist, that this does happen. This is part of evolution that we do agree with. because we can see it. But we'd call it adaptation. That's kind of what we refer to it as. So you have, like, say, bulldogs. We know what bulldogs used to look like before they got flat-faced. Weren't always flat-faced. That's why they kind of breathe like that, because they're not supposed to be flat-faced. We bred them to be that way, and so they have a hard time breathing. It's actually really sad, but that's just kind of how it is. But it's still a dog, and it still can largely breed with other dogs. And one of the issues is you start to breed too much, and sometimes they're unable to breed because you've messed up their genes and all that kind of stuff. But largely they're able to breed, even though it's kind of weird, and sometimes they might not work exactly right because they're different sizes and all that kind of stuff. They're still dogs. You still have 4 legs, ears, snout, all that kind of stuff. They're still dogs. Obviously, you're not going to look at them and be like, dang, that's a really cool cat. That's a really cool horse. You don't think that. There's no part of you that's thinking that because obviously they're not. And so this part of evolution does not disprove the Bible, does not disprove God. Rather, what it shows is that God has made his creation malleable, so it can change a little bit. You see that with humans. Another issue we have with speciation, when we use the term species, a lot of times we say, oh, we're the human species. Yet if you were to use speciation the way we use it with animals, like dogs, you would say we're different species. You say, well, there's the Asian species, and then there's the African-American species. Like, hold on a second here, right? But that's kind of the terminology you use because you have people who are very hairy, and you have people who don't have a lot of body hair. You have people with black hair, and people have blonde hair. You have people with really thick curly hair, and people with no hair. You have people with large noses, small noses, people who are very tall, people with long limbs, smaller limbs, all that kind of stuff. You have all these different things that if you put all those distinctions together, it starts to look like, well, they're very different than I am. And from an evolutionary point of view, that's kind of what you get to. Well, maybe they are a different species than I am. Maybe we'll see that later on with Neanderthal and that kind of stuff, where it's like, well, they seem so similar to us, but they must be a different species because they have all these different traits. But if we were to say that about Neanderthal, wouldn't we say that about people today? And all of a sudden, that's where you have a lot of kind of racist thinking, which is they are different from me in a way that's very distinct. They are not like me. But we looked at that Bible verse that says, from one blood God has made all nations. We are all related. Even though we may have physical differences on the outside, we are still very much the same. So mutation. This is the main way that scientists like to explain evolution took place. How do you get, let's say, a land animal to turn into a whale? That's kind of where they believe whales came from, right? Because they breathe, so it must have come a fish into a land animal, back into a sea creature, that being a whale. And so they say, well, look at mutation. This is one of the things that I brought up in that quote at the very beginning. And so this is a mutation of a two-headed snake. We'll look at a couple mutated animals right now. So you have a double-headed snake. Here is a 6-legged dog. You can see he has 4 legs in the front. You can't see him, but they have 2 legs in the back. This is a dog with a little unicorn horn. That's a tail right between his eyes. It doesn't affect him anyway. He's doing completely fine. He's healthy. I had to know because I wanted to know, like, is it affecting his brain or not? I don't think it wags very much, but you know. But that's a mutation. This is a 4-legged chick, or I think Titus calls them chickadees. If you know, one thing, we'll talk about this, but notice that back foot doesn't look exactly right. Well, pay attention to that. But it has 4 legs. And it has, instead of having little wings, it has 4 legs. It's kind of cool looking. This is a 4-eared cat. Technically, it still has 2 ears. It just, the outer part is duplicated. And so what we see is, did someone say meow? What we see is, we see all these different mutations. And this will say, well, these mutations will eventually lead into another animal. That cat will eventually evolve into some other kind of creature. But notice what we saw. That snake had a head, and all of a sudden it got another head. That dog had arms, and all of a sudden it got another set of arms. Had a tail, and all of a sudden had another tail. All we've seen is the same information duplicated erroneously. We've not seen new information. One thing that's also interesting, we've been breeding dogs for hundreds of years, centuries. We've been because we love dogs. Humans and dogs have been around since like the very beginning, it seems like. Obviously, we've been around since the beginning, but we've been together like that good kind of relationship since the beginning, it seems. For whatever reason, we get along well. But you'll never see a dog that has wings, nor a dog that has gills. No matter how much you try to breed them, try to put them together, they'll never develop those things because they do not have the genetic code within them to make wings. They don't have the genetic code to make 4 limbs, and maybe they'll make 6 limbs. But still, it's limbs that it has. It doesn't get cat limbs, doesn't get alligator limbs, doesn't get scales. It gets those kinds of things. It gets the same stuff it has, but duplicated. So when you look at mutation, one of the issues with mutation is, why don't we see them mutate into other things? I think too many times we think of mutants, we think of like the X-Men. Oh, and you get the mutants, you get wings, and you get mutants, you turn into beasts, you get like those bone claws that Wolverine has, and you're like, oh, that's so cool. Where in the world are you going to get that kind of stuff? Why would you ever have that kind of stuff? Technically, I guess you could get bone claws, but that's like horrible. You're just getting bone spurs or something like that coming out. They're not going to function the way they do in the movies. So here's an issue, with mutation. And so this is a cat that was born without an eye and a dog that was born without limbs. And that ties into mutation. I'll read a quote right now. It says, a single mutation can have a large effect, but in many cases, evolutionary change is based on the accumulation of many mutations with small effects. Mutational effects can be beneficial, harmful, or neutral. Pay attention to this wording. It's very important, because what they said earlier on, that quote we first read, said that mutation is one of the leading causes we get from animals from different kinds to form into other ones. This is what it said again. Mutational effects can be beneficial, harmful, or neutral, depending on their context or location. Most non-neutral mutations are deleterious, meaning if it's neutral, it doesn't affect it very badly. We saw that with a lot of those animals we saw. The one with the tail, the one with the 4 ears, it's pretty much doing all right. But the most non-neutral ones, that means if it's not neutral, it doesn't affect them negatively or positively, most non-neutral are deleterious, meaning it gets rid of information. You're not getting more information, you're losing information. You're losing an eye, you're losing limbs. Which is interesting. It says, in general, the more base pairs that are affected by mutation, the larger the effect of the mutation, and the larger the mutation's probability of being deleterious. That is, the more mutation you get, the more of that mutation you get, the more you lose. So their main mechanism for changing animals from one kind into animals of another kind, right? They don't have the genetic code. Of course they don't. Well, maybe it mutates into new code. What does it actually do? The mutation doesn't add code. It deletes it away. It gets rid of it. It deletes it away. It gets rid of it. So this is what you're ending up with more of this. So instead of what evolution teaches, which is that you become more complex, you become more greater, you have more traits, you're losing traits. You become less complex. You're actually going backwards. You're losing information. You're not becoming more complex. You're becoming less complex. So it just breaks down. This shows that mutation's main mechanism doesn't actually build up like they say. It just breaks things down. It actually causes more problems than it solves. Because what happens when this one mixes with the one that also has no arms? Well, that's going to give birth to other ones that have no arms. And that mutation is going to spread, and it's going to delete more and more material, because that's what mutations do. But there are examples of beneficial mutations. We'll look at those. Obviously, they said there's some that benefit, so let's look at some that benefit. We're going to look at one specifically. You can try to look up the other ones. There's very few, in all honesty. You try to find. One of the other ones they mention is, well, before we look at this, is fruit flies. And they'll say, look, we've seen mutation of fruit flies. And they've done that in the lab. They get fruit flies, and they try to make them mutate. And like, look, this is beneficial mutation. They showed a fruit fly that had 2 wings, and they're like, look at this one. We made it mutate to have 4 wings. And they go, that's a beneficial mutation. Now it has more wings. But then you see the fruit flies fly, and they can't fly very well. Why? Because the fruit fly was made to have 2 wings, not made to have 4 wings. One of the issues you saw with that dog that had 6 legs, oh man, it's going to run faster. It has more legs. It can run twice as fast, 3 times as fast, whatever, half times as fast. It's going to run slower because now it has those legs weighing it down. Not only that, but those legs don't function very well because it's meant to have 4 legs, not 6. And so when that genetic code starts to change it, it's going to function more poorly because it's made to have a certain way. It's made to be specified according to its genetic code. When you start to go against that code, you start to change that code, it starts to create errors. We see that with computer programs. Why does all of a sudden your computer just shuts down? Well, it's doing it as a fail-safe because things are messing up. It's not going correctly according to the code. So you've messed up somewhere, so it needs to reset. That's the same thing with animals. And so this is an example of a beneficial mutation, they say. And so this is a sickle cell anemia. So this is what our red blood cells actually look like. This is how we want them to look like. That's healthy. They function correctly. But this is sickle cell anemia. When you have that, your blood cells turn into sickle cells. They look like a little sickle. They don't function as well. They don't work correctly. And so Italian researchers studying the population of the African country Burkina Faso found a protective effect associated with a different variant of hemoglobin named HBC, which is a variant of sickle cell anemia. People with, this is the very important part, people with just 1 copy of this gene are 29% less likely to get malaria, which is a loss of blood cells. It causes hemorrhages and can lead to death, that kind of stuff, horrible. But they're 29% less likely to get that if they have sickle cell anemia. While people with 2 copies enjoy 93% reduction in risk. That is, people who have more copies, a worse off sickle cell anemia, are more likely, 93% less likely to get that HBC, that variant of this, which is a horrible variant that leads to death. And it goes on to say, and this gene variant causes at worst a mild anemia, nowhere near as debilitating as sickle cell disease. What they're saying is, and I'll put this in other terms, you're less likely to get breast cancer if you remove your breasts. You're less you know what? You're 100% less likely to get hearing damage if you're deaf. In fact, if you're blind, you can look at the sun as much, you can stare at the sun as much as you want. You're 100% less likely to get eye damage if you look at the sun if you're blind. That's what they're saying. Or if you got you're an dual amputee and you got both your legs cut off, you will not get athlete's foot. Isn't that incredible? That's such a great benefit. Like, athlete's foot's terrible. You don't want to get that. But you're laughing because it's so silly. Like, what do you mean? I lost something in order to gain something else? This isn't a benefit of mutation. This is a byproduct that happens to be better than the alternative. That's all it is. But this is what they'll say. This is a beneficial mutation. In order to get this beneficial mutation, you must suffer first. That doesn't sound very good. But again, this is the stuff that they point to. I should have put that up there. That's showing that. Yeah, 29% likely, less likely, 93%. It's like, oh, isn't that great? It's great for the people that have that to know that you're not going to get something else that's worse. But you don't want to get that in order to get this. It's kind of ridiculous. There's another quote. I don't think I put it on, but it says, nonetheless, most studies of recent evolution involve the loss of traits, and we still understand little of the genetic changes needed in the origin of novel traits. That is, yeah, mutation with all these benefits, we know that's what it leads to. The only issue is we don't really have any evidence that it proves that. And we're still kind of thinking about it. It's still a mystery, but we know it works, and we know this is what leads to it. We just don't know how it works. Again, it's that idea of it's based on assumptions. It must be mutation because we don't know what else it could be. Okay, let's look at the mutations. What do we have? Well, it doesn't really work out yet, but we'll find it eventually. It's a lot of that kind of stuff. We'll find it eventually. Eventually, we'll find it. Just trust in it right now because it's the only thing we have. So that's microevolution. I hope that was pretty plain and simple. We do believe in adaptation, but we do not believe that mutation leads to benefits. It only leads to worse things. So this is macroevolution, the idea that basically what everyone thinks about with evolution, that we evolved from land animals that evolved from reptiles, which evolved from amphibians, which evolved from fish, which evolved from a single-celled organism. So macroevolution generally refers to evolution above the species level. Again, showing that issue with speciation. Macroevolution encompasses the grandest trends and transformations in evolution, such as the origin of mammals. This is the big stuff. This is what everybody points to with evolution. We can prove, and we'll look at some of the ideas, these transitional species and stuff like that. We can prove that we came from other animals because of certain traits. And so this is one of the things they point to. We know macroevolution is true, and it must be true because of all these similarities. You'll notice the different bones. You have the humerus, the radius, ulna, carpals, which are that part in your wrist, the metacarpals, which is the part in your palm, and then the phalanges, that being your fingers. Well, notice in the cat, you have the exact same thing, exact same makeup, exact same position. Same thing in the whale, same thing in the bat. Obviously, with colors, it makes it a little easier to figure that out, but that's what we see. Look how similar it is. Thus, we can conclude we must be related. Sure, maybe. I mean, there's something in common there. There might be something to it. Let's look into that. So one of the things they point to is the fossil record. Dopey-looking fish thing. So this is a quote from them. They said, one frequently cited hole in the theory of creationists claim there are no transitional fossils, aka missing links. Biologists and paleontologists, among others, know this claim is false. And this is what a lot of people do. You guys are so silly and so dumb. You guys say there's no missing links. People have said that for years. Well, the evidence has changed. We actually do know there are missing links, and we'll look at one of them because there really aren't very many to find. We might look at two tonight. This is a stupid looking thing. I'm sorry. It's like it looks like someone drew Dumbo like a child or something like that. And that's what it looks like. It's called a Moatherium, which is supposedly the ancestor of an elephant. This, they'll say, is a transitional species from an elephant to the elephant's ancestor. There are some issues with that, of course. We don't have any of these alive today. So looking back on our lesson on fossils, we don't know if this is even what it looked like. This is the skeleton. You'll notice some weird things. Where did you get that big old ear? Let's go back. Never mind. Too far forward. Okay. See that? No ear. But we know it must have a big ear because it's the ancestor of the elephant, so it has to have a big ear. You'll also notice over here, that's where the nostril would be. Well, it must have a long snout. I mean, you don't see it, but it must have it because it's the ancestor of the elephant. How do you know it has a long snout? How do you know its skin color is like this? How do you even know that its fat is shaped the same way? How do you know it didn't have fur? How do you know it didn't have feathers? How do you know all these kinds of things? You don't. But again, we talked about that with fossils. Fossils only tell you that this thing died and it was preserved. Doesn't tell you where it came from, doesn't tell you what it led into, doesn't tell you if it had a big family, small family, doesn't tell you if it was alone. You don't know any of that stuff. All you know is that it died and it was preserved this way. And yet they'll claim, well, that we know we have transitional species because we found stuff like this. This is the ancestor of the elephant. But how do you know? Again, going back to fossils, you can't date the fossils. Remember, you can't date them with carbon dating, nor can you date them with other forms of radiometric dating because there's not a rock. So you have to go to something else to date it. Well, then how do you know these are even related? You can't use DNA to, they must be connected. We can see they're connected. They share the DNA. You don't see that. You just see bones and other bones that turn into fossils, and we think they're related because they look similar. That's an assumption. They must be related because they look similar. I'm sure if someone came in now, they walked through that door, they looked at me, and I told them, hey, pick out my 2 parents. They look around, and they go, who do I look most similar to? Oh, maybe I look similar to Brother Jason, or maybe to Brother Anthony. Why? Because they have glasses, they have facial hair, they're light-skinned. That must be, no, my dad's over there. What? He's dark-skinned, he doesn't know. Yeah. Most people will probably, what? I don't know. Maybe they'll look close, I can see some similarities. But you're not gonna know, you're just looking for similarities. A lot of times people don't think my sister Megan is my mom's daughter. That's your daughter? What in the world? I thought you kidnapped that child. But they'll look and they'll think, that can't be related. Why? There are not enough similarities there. But that's an assumption, and it's a false assumption. It's a wrong assumption. So to do that same thing here and say, well, it must be related to the elephant, even though it doesn't really have any. Where's the tusk? It has a lot of features that are not related. But they say it is because of similarities, and that's how they are with all transitional fossils. There's some we're not going to look at. There's a giraffe fossil. And so this is a transitional fossil. All it is, it's almost the exact same skeleton as a giraffe, but the neck's a little bit shorter, and the body's a little bit smaller. It could be one of 2 things. Either it's a baby, or it's a small giraffe. I don't know if you know this, but giraffes do come in different sizes. Not all giraffes are the exact same size. Just as not all humans are the exact same size, not the same height, not the same weight, not the same build. Some people have broad shoulders, some people have narrow shoulders. It's the same thing in the animal kingdom. Animals are the exact same way. You got big animals, you got small animals. And they're the same kind of animal. Even the mother and the dad, the mother and the father and the children can be different from each other in terms of the way they're shaped and the way they're built. Because we have, again, that adaptation where we have the same information, but it's being changed differently. It's being changed. So the issue with transitional species or transitional fossils is that we don't have it. There's something Darwin quoted. He said, why, if species have descended from other species by fine gradations, do we not everywhere see innumerable transitional forms? That's the other thing. Because again, this didn't just happen. This thing just didn't turn into the elephant. It slowly turned into the elephant. So why don't we find something that's in between this, that slowly gets that snout, something that's in between that slowly gets those ears, something that gets a little bit bigger, and it slowly becomes, why don't we see any of those things? We don't. One issue we don't see it is because fossilization, and this is what they'll say. Back when you look at fossils, they look, all this fossil evidence is so great. And yet when you point to the transitional fossils, they go, actually fossil evidence is not that great because there's not a lot of fossils. Even when you get to the fossils, it's not very complete. And so you have a lot of pieces of fossils, and you have, and it's funny, they backtrack on it on this area, but over there they don't. We know we have fossils, and now we're not so sure. But again, we don't see all those transitional species. And you might not expect to see them because fossilization is so rare. So then why do they hold to it? Oh, it must be true. Yet we don't have all that evidence for it. It's just, again, based on assumptions, which is kind of crazy. Here's another thing. This is a tapir. It's actually alive right now, and this is the elephant, of course. Well, look how similar they look. He's got a long snout. He's got a long snout. They must be the same. Maybe tapirs evolved into elephants, or elephants evolved to be smaller tapirs without tusks. Are we going to think that? No, we're going to look at these things and say they're 2 different kinds of animals. Yet if you find their bones, and maybe you find part of that soft tissue together, you might conclude they might be the same. But we know they're not even close to being related. Yet that's what we're looking at with fossils. With fossils, we just look at the bones of these creatures and go, they look similar enough, they must be related. Yet if we were to see them live, all of a sudden that changes everything. So if they're alive, we can know for sure if they're related or not. If they're dead, we don't know, so we assume they are. That's kind of the idea. Again, it's that weird a thing where you're assuming it must be true. Universal common descent must be true, therefore it is. But we don't have any evidence for it, we just kind of believe it is. It's that issue. You'll notice also the tapir looks more similar to that other creature than the elephant. But why did they want to say it's the elephant? I can't tell you. Maybe because it is a tapir, I have no idea. But it's interesting that that's kind of how it is. You could make the same assumption. Well, dogs have 4 legs and a tail, and cats have 4 legs and a tail. They must be coming from a doggish cat ancestor or something like that. Well, no. Just because you have similar features, again, does not mean you are related or even closely related. Well, Brother Anthony and I and Brother Jason and I, we have glasses. We must be related. We're not. I don't think we're very closely related at all. I'm sure we diverge really far before we finally get back to, like, I don't know, Noah maybe. But you can't assume that just based on similarities, visually speaking, and yet that's what they do. And they say that's the evidence for evolution. Not very good. So that's what they use with the fossil record. So the fossil record, again, is not very reliable. It's just it's a record of death. There is, however, something we do find in the fossil record. It's called the Cambrian explosion. That's Cambria exploding. Sorry. There you go. I was trying to go on, but it kept on going back. Yeah. That actually happened. That's how it was. It was recording. Yeah, so the Cambrian explosion. So again, in the fossil record, they base the lower levels are the older places, the lower strata. Then the higher strata, the higher rock layers must be younger. And so you have the Precambrian and the Cambrian. What we notice is in the Precambrian, we have certain kind of fossils of different kinds of sea creatures. They're very different kinds. All of a sudden, we get to the Cambrian explosion. The reason they call it the Cambrian explosion, because we get all these diverse sets of creatures that don't seem to have any relation to what came before. And so they go look at it and they go, I don't know how to explain this. And this is how they've looked at it for years. How do you explain that these became these when they don't look anything similar? Or, well, they used to think that. We'll talk about that right now. But all of a sudden, it just seems to come out of nowhere. And within they say 10 million years. They think now probably it's closer to 5, anywhere between 5 to 10 million years that this happened. That's pretty quick in terms of geologic time. Obviously, it's millions of years, so it's still long. But it's pretty quick compared to what they say for everything else. But they'll say it's still long enough to make that evolution from this to that. So Darwin had the same problem. He looked at the Cambrian explosion. He said, I don't know what to do with it. He called it the Cambrian conundrum. And he argued that the incompleteness of the fossil record gives the illusion of an explosive event. But with the eventual discovery of older and better preserved rocks, the ancestors of these Cambrian taxa would be found. Again, Darwin holds to the same thing that people hold to today. I don't have the evidence. I cannot prove it, but one day we will. 150 years later, we still haven't found those. We haven't found those transitional species, right? They're very much disputed because we look at them and like, how do you know? Well, it's just an assumption. So we can't turn to those. And obviously, we have very few. If you try to look them up, they're going to show the same kind of one, that weird-looking fish thing. They'll try to look at whales. They might bring up the giraffe or the horse, and then they bring up that weird-looking whatever that Dumbo thing was. It's very small. Why is it so small? You expect to see so many. I mean, you're talking about millions and millions and millions, but you're not seeing any of those. You see very distinct species or different kinds of animals as well. But you don't see the in-betweens. Why don't you see very few in-betweens? Why don't we, I mean, you're talking about millions and millions that have to go in between. Why don't we see at least a few more than this? We see very, very few, which almost seems like they don't exist. So how do scientists address the idea of the Cambrian explosion? How do we fix that? Well, what they do, if you look it up, I tried looking up nonstop. I keep on going, I'm like, someone explain this to me. They keep on saying the same thing. It's a non-issue. It's a non-issue. We've already explained it. They're similar enough. Similar enough does not mean they're related. It doesn't matter. Oh, it's similar enough. A cockroach is similar enough to, I don't know, some other kind of bug. Those little flat beetle bugs, whatever. They're similar enough. They're not the same. Well, they're similar. A centipede is similar to a millipede. They're not the same. They're still different. They might be, that one actually a pretty good example for what's related. They look similar. They are similar. But other ones that look similar, they're not. So you can't know. Again, it's based on assumptions. You don't know unless they're alive, and then you can compare them and check that DNA, all that kind of stuff. And so they look at it and say they are similar, so therefore it's already been swept under the rug. Don't worry about it. We've explained it already. But they haven't explained it. Let me see your research. And they just keep on saying, no, don't worry about it. Don't worry about it. What do you mean, don't worry? It's this weird thing that we've looked at with those videos when someone says, I'll send you some papers, or someone's already explained it. Someone else already figures it out. I don't need to have time to figure it out. Because when you try to figure it out, you can't find it. You keep on looking. I'm eventually just going to give up. I'm just going to accept it. They're smart. There's no way they falsified their papers or whatever. It's not like people do bad things at all. But that's kind of the issue. I lost my place real quick. So yeah, that's kind of how they look at it. Again, everything's just based on assumptions. Similar features lead to relation. The last thing we'll look at is survival of the fittest. Again, this is that speciation that we see where it leads to different kinds of things, also known as natural selection. So it is a simple statement of the fact in dangerous circumstances, only those individuals most adapted to their environment survive. So this is the idea of survival of the fittest, of natural selection. That is, that creatures, in order to turn into other creatures, they get those better genes, and those better genes, those better traits, and that's how they survive. The issue with that's accepting a premise, again, based on assumptions. The assumption that only the best survive. But that's not true. Because what happens when a landslide hits, and all the best that's where they live? Well, then the best get wiped out. How do they account for that? They don't. So what ones survive, the best or the luckiest? The luckiest. What happens when people come in and hunt them out? Did the best survive or the luckiest? The luckiest. Sometimes you see animals don't necessarily always go for when they're hunting, predators don't always go for the one that's the weakest. They go for whatever one happens to be the closest to them. Maybe it's the one that it fell off a cliff. Was that the weakest one? Does that have the worst traits? No, the cliff gave way and it fell, and they go after that one. It's the baby that had a little bit too much fun and ran off. Does it have the worst traits? Not necessarily. It just ran off, and that's the one they got. It's the weakest, but it's not necessarily the worst traits. So it's not really the survival of the fittest, it's the survival of the luckiest. So again, it's based on this assumption, again, you're just hearing that all again, assumption, that the fittest survive, when in reality, you can't say that for sure. It could be the fittest, it could be the luckiest. And it seems more likely it's the luckiest, because so many different things you can't account for that happen that kill these things off. Why did the dodo birds die off? Well, they just weren't that fit. Not necessarily. The environment changed, and then they got driven off and got hunted. How can they account for humans hunting them down? They just can't. So there's that issue. Oh yeah. So again, the last thing we'll look at is what is the mechanism? So in order, again, to get, and I briefly mentioned this, in order to get an animal to go from one kind of animal to another kind of animal, you'll need genetic material. You'll need the genetic code to change it from that kind of animal into another kind of animal. And so what you see here is you see the chromosomes inside the cell, and that kind of stuff forms the DNA. DNA is very complicated. It's small things that form other things that form other things. But you'll notice this is kind of how we did that. I talked about that a while ago. I got something right there. See that TCGA, that's kind of the way we define it. That's what the code is. That's how it's laid out. And they're laid out differently. And so it's TA, TT, TG, that kind of stuff, GC. And it's all going around making that code that makes the arm, that makes the skin, that makes the blood vessels, that makes all that stuff that's within us. That stuff is unique to every single kind of animal. The stuff, my DNA, even between us as humans, my DNA is different than Brother Jerry's DNA. They're similar, we've got human DNA, but my DNA makes me look like me, and his DNA makes him look like him. That's very different DNA. I don't have the DNA to make me look like Brother Jerry. He doesn't have the DNA to make him look like me. He has the DNA to make him look like him, and I have the DNA to make me look like me. Especially different when you see it with animals. I will never have the DNA to make myself look like a wolf. There's a lot of people who want to be wolves. You can't. It won't happen. It doesn't matter. You do not have the DNA to make that happen. That's kind of weird. But you just don't have it. You just don't have that DNA. You'll never be able to turn into that thing, or the wolf will never be able to turn into a human. You'll never have that kind of stuff because it does not have the genetic code to make that happen. There's a quote here. It says, an organism's genome is the sum total of all its genetic parts, including all its chromosomes, genes, and nucleotides. A genome is an instruction manual that specifies a particular form of life. The human genome is a manual that instructs human cells to be human cells and the human body to be the human body. There is no information system designed by man that can even begin to compare to the simplest genome in complexity. Again, talking about how complicated this stuff is, and yet it can't do what it can't do. It's specified for one type of thing. One thing to look at, that information sounds like someone designed it. When you look at the code in a computer, there's no way you're thinking it just happened randomly. Someone designed that. You look at the code in human beings, it's so complex, we can't even replicate it. It's that complex. With all the coding we do, all the artificial intelligence, we still can't replicate something like this, like DNA. It's that complex. And somehow it just developed over natural processes. Somehow, this is the kind of stuff where you see information, and all of a sudden you conclude, no intelligence. That's crazy. When you see information, you conclude there must be intelligence behind it. And for whatever reason, they don't, because they don't want to accept that. Because the issue lies, if they accept that everything comes from nothing, then the only way they can get they can get information is from nothing, that things just happen to naturally form. But things don't naturally do that. So the other viable mechanism is God, but they don't want to accept God. God does not exist. Therefore, it must be some other way. And yet every time they look at other ways, it doesn't work because they believe God does not exist. That's, again, talking about our worldview shapes the way we do things. Their worldview shapes them to be, they're blinded. They do not want to accept the alternative, that there must be intelligent design, that God must have created all things, because that goes against what I believe. Well, again, it doesn't matter what you believe. It matters what's true. Does God exist or does he not? Is there intelligent design or is there not? Is there evidence for evolution or is there not? And what we see is the evidence is against it.